Relational databases. So relational databases in the sense it's going to describe how the data are related and those data are how they bonded with the relationship. So those are defined in this relational database. So this relational database includes based on the relational model because we have various model over the database like a network model, relational model, object-based model, semi-structured model like that. But most commonly used model is the relational model. So this follows the main relational model and it includes the collection of tables. For each and every databases it's going to follow a separate table in order to maintain the same. So it's going to maintain the data along with its relationship. So this describes the relational databases. So data in databases are saved in the form of tables, that is known as relational database. So here the table is important database here. So the table in the sense it includes n number of rows and columns. So each table may have n number of columns like multiple columns. Each column may have unique name. For example, a particular table includes 10 columns in the sense each and every column must have a unique name in order to identify the same, in order to identify the uniquely over the data, it is following the unique name. So that is the importance of the table. So it's following the relational model. So it is very important because vastly most of the concerned organizations are using this tables. So example for this table is here I have different three tables. First one is a customer table, account table, finally the depositor table. And the first one is customer table, which includes the customer ID, customer name, customer city. So these are the three columns, or it is also known as attributes, which is records. Like records in the sense this is each row represent the record. This table, individual table, the name of the table is customer, which includes three columns, 1, 2, 3 columns, then 3 rows. So the rows represents the records over the same. So this database includes 3 attributes and 3 rows. The same way here the account number and balance comes under the account table. So it includes a number of account number as well as corresponding balance in dollars or something else. So this table represents the account detail of the particular database. The same way next one is customer ID and account number. So this depositor table includes customer ID. This represents the customer ID of the account number A111. Likewise it includes n number of customer and its account number. So while considering these three tables, this first table includes customer ID, customer name, customer city. The second one is account number and balance. So the two separate tables about the customer in the sense, so these two relations are combined, and finally giving the third table like a depositor table. It includes customer ID from this customer table. Then second one is account number from this account table. So these two relations are relations, and it is also internally called as tables. So while combining these two relations, it is forming the third relation called depositor, which includes two columns like customer ID as well as account number. So while combining this previous two relations, there is possibility of redundancy like 201, the account number again 201, it is repeating. This is the problem over here. The same way customer ID also repeats. Customer ID for this customer ID. So this is repeat. This is the problem, like the redundancy over the database is possible. So let's see how to avoid the same. So this is the problem, combining the any two or more relations are combined. So these are all the sample relations. The example. So we'll see the how to manipulate those queries and as well as how to design the database using this DML and DL. So first one is DML, data manipulation language. So it provides more application operations to perform the to extend customer dot customer name. For example, data manipulation language in the sense, using this we can perform the retrieving operation, deletion, updation as well as modification. So among those operations, here one example is defined here, like select customer name from the relation customer, where the condition customer dot customer city. So this describes customer dot customer city equal to Chennai. So it's going to extract the data from the database where the customer city equal to Chennai from the relation customer. It's going to extract only the customer name. Among n number of columns, it's going to extract only the customer name from the relation customer where the city is Chennai. So this is the very simple example for extracting the data from the database. Your database name is customer. So this is the data manipulation language providing the facility to extract a particular column from the database. The same way here, one more example under the data definition language, which is used to define or design the database. So designing the database includes using the command like create table. Using the command like create table, here account is a database table or a database name. So it includes here two columns are included, account number as well as balance. So account numbers, the data type is varchar, variable characters. So that is represented here varchar. Then balance is represented as integer. So here account number is a type varchar, includes this 10 represents, it allows only 10 characters. Up to 10 characters you can define the account number. The same way balance will be represented in the form of integer. So here while creating or designing this database, which include two columns and its corresponding data types. So while creating this, we can set the integrity constraints also. Whenever required, constraints are added, because this DDL provides the integrity constraint in order to validate the database data available in the relation. The entity relationship model, this describe the differentiate or relations between the various entities. So among the various model over the database, this is also a important model, entity relationship model. So this is describing the relationship between the various entities and its relationship. So for that, they use the following diagram drawing images or symbols in order to describe the same. For example, rectangle is used to represent the entity set. Particular entity set is represented with the rectangles. Then attributes are represented with the ellipse symbol. Then the set of relationship among the entity set. How to represent the relationship in the sense diamond symbol is used to represent the relationship between the entities, two entities. The same way line represents the to connect the both entities as well as the relationship. For example, line is used to connect the one entity set to its relationship symbol like diamonds. From diamond symbol to again from the relationship to another entity. So that is the purpose of this lines. It is also known as connector. So these are all the most commonly used symbols in order to describe this entity relationship model. So here the example sample ER model is described here. So here customer is one of the entity set. The another set is account. So here define the table like customer. So entity set in the sense but a particular table or a database. So here one more entity or table. Database table is account. So these are the two relations or two tables. So which are connected through this symbol like depositor. So this entity set is represented as a rectangle. This is rectangle. This is rectangle. So how these two entities are connected? The sense customer depositor over the related with the account to the bank. So these two are related with deposit. So this is specified within the diamond symbol. So this customer relation and its relationship symbol depositor, these two are connected through this line. The same way the relationship with the other entity set is connected through this line. So the same here one more thing is customer customer includes the following attributes. Attributes in this is also known as characteristics of this customer. So customer includes customer ID, customer name, customer street or city. So it may include n number of attributes over here. So whatever the attributes included here, it may be added here. Like 3 attributes are added in the sense it may be represented in the form of ellipse. So here underlined attribute represents the primary key or important key over the same. So this represents the like this is going to uniquely identify this customer relation. That is why it is underlined. So these are all the attributes connected with this relation. The same way here also account relation includes account number as well as balance. So here account number, so this being the primary key for this relation account. So this account number is going to uniquely identify the data available in the account relation, and also balance also non-primary key. So here the customer and account relations are represented in the form of ER diagram, like entity relationship diagram, and then there are symbols representation. So we can clearly identify these two are related with the depositor or depositor over the same with the following attributes with its primary keys. So this is the example for ER diagram. Then one next topic is normalization. Normalization in the sense like this is also one of the method to design the database without some redundancies. Redundancy in the sense database in the sense like the number of data is stored in the database. So while designing the database, you need to consider some points like to avoid the unnecessary redundancy as well as easier retrieval of the information. So based on these two constraints, this database is designed. So that is known as the normalization process. So while following the normalization rules over the database, it must have the redundancy less or non-redundant values within our database. So our database data must be valid. So in that purpose we are going for this normalization. So this normalization when it may happen in the sense, in order to describe the normalization process, first we need to discuss in case of redundant data, we includes this two things like the repetition of information. So the data available, particular account detail is available in the sense again with some databases allowing the same, like it may be more number of multiple times of occurrence of the particular data is available over the database. So that is the that leads to the memory increasing the size of the cost of the memory size may increase. The next one is inability to represent the certain information. So in case of the same way, it is the inability to represent the required data. So repeatedly this adding the data like this, like redundant data in the sense whatever the data maybe we are willing to add over the database may not be added. So these are all the two major problems considered while before applying the normalization over the database. So for example, this depositor table includes 3 columns: customer ID, account number and balance. Seeing here itself, the numbers account numbers are repeating. The same way here account numbers, different account numbers are repeating. So here the number of occurrence of the same data is repeatedly occurring while displaying the database. So that is known as redundant values. In order to avoid the same, we go for normalization. So the normalizations are the different levels or different types of normalizations are there. So it's going to avoid the repetition of the same, like account number 201 is repeating this table. So we can avoid the same while considering the large amount of data will be vastly reduced and will get the valid database. So that is the purpose of this normalization. Keys in the database are playing a major role in order to extract the data and also store and retain the data. Keys are used to uniquely identify the particular column from the database, because in order to validate our database table or relation, we need to identify some keys. Through that key only we can maintain the other keys keys in order to effectively extract the same. So here how they are defining the key in the sense it may uniquely identify the relationship. Whatever the relationship we may have, that may be uniquely identify with the set of attributes, those are known as keys. So here a number of attributes, one or more attributes are considered as keys. So we'll see what are all the various types of keys available in the database. So types of data keys in the database are super key, candidate key, primary key, and foreign key. So these are all the various keys in order to combine the various relation to effectively extract the data from the database. So first one is super key. So here super key in the sense how to identify or how to define the name like the super key in the sense consider a particular relation. In a particular relation we have n number of attributes. Among the n number of attributes, set of few attributes are identified as super keys which are uniquely identify the rows or records in the database. So those are all known as super keys. For example, student is a relation here. So it includes a number of attributes like roll number, name, age. So these three can uniquely they are saying we can identify like these three can identify the records uniquely within the whole database. So that is why it is known as super key. So we can differentiate the whole database data with the roll number, corresponding name, corresponding age. So these three are considered as a super key, which is going to uniquely identify the data available in the data available in the database. So we'll see the candidate key how it will be different from this super key in the sense. Candidate key in the sense it is also it's also identifying the differentiating the data available in the database, but how it is differentiating in the sense one or more set of attributes are uniquely identifying the database in the data. For example, here super key which includes it also allows null, like unique as well as null. Null also it is allowed. Here there are those that null is not considered when considering the candidate key. So here it's going to uniquely set of attributes uniquely identifying the database available in the data reservoir. So for example, consider that car as a relation. So it includes the following attributes like license number, serial number, make, model, and year. So these are all the number of attributes. So among these attributes, considering itself license number and serials number. So see these two maybe most of the entity may have, most of the car may have different or unique numbers. So these two are considered as candidate key. So in this way this uniquely identifying the data available in the database. So we are based on this example license number and serial number. So we can identify like how to select the candidate key in the sense the attribute which may have unique value for each and every attribute every relation of the name like car. For each and every car it may have unique separate license number and its corresponding engine serial number. So based on those as a condition we can select the candidate key. So this is the in this way the super key and candidate key are differentiating. The next one is primary key. Primary key is a key that is an attribute from the particular relation which is uniquely identifying the data available in the database. For example, employee is the relation. It may include a number of attributes like employee number, employee name, date of joining, date of birth, salary, job, department number. So among n number of attributes, any particular column or attribute is considered as the super primary key. So which is going to uniquely separately individually identifying the data or records available in the database. So based on this example, employee number. So it may be like the student register number for the students. It's the same like this. So each and every employee available in the particular organization may have unique separate number. So based on this number, I can identify the or validating the database available in the repository. So that's why, so here employee number is acting as a primary key based on this relation. The same way like finally foreign key. So foreign key in the sense it is while considering the foreign key there are minimum two relations are involved. So here more than two relations also can be involved. But within the particular relation we can't able to define the foreign key because foreign key in the sense primary key of the particular relation matched with the primary key of the other relation. Or it depends on the other relation. So that is it is known as foreign key. For example, the department number available in the department relation. So employee also includes a department number. So in this case, if you want to display the employee detail depends on based on the employee role enrolled in the department number available only. It is allowing in the sense. So here employee details it may be displayed or entered based on the department number available in the department relation. So other than the department number available in this department relation, it won't allow the records in the employee number. So in that case, we can use the foreign key in order to depend or related in order to relate any two or more relations. So that is the purpose of foreign key here. So one or more relations are each other. So this is the purpose of foreign key. So in the primary key in the sense considering it is only for the particular relation. But in case of foreign key in the sense minimum at least minimum two relations must be involved. But we can consider while considering three or more relations also we can use this foreign key. But while adding or deleting the foreign key constraint, foreign key process in the sense that we must be parent or its corresponding department details, like corresponding details must be deleted. While foreign key is disabled in the sense, it is also corresponding basic or reference relation also to be deleted. The next one is relational algebra. So relational algebra is here more query languages involved. Query language in the sense we have the database relation. So it includes n number of data. Also n number of data even though we have a high volume of data at a particular situation we require only the portion of the database or tiny portion tiny of the database details. So in that case we can use the query language which is going to extract the particular required data just only requires in the particular instant. So we don't need to load the overall detail in order to select the same. So in order to satisfy the particular user or programmer detail, only the required data is extracted. So for that case the relational algebra concept is used. So it is considers two categories like programming procedural languages, second one is non-procedural languages. So in order to extract the data we need to consider two types of languages. Procedural language in the sense we need to instruct the system to extract how to extract the required data from the database. So that is known as relational algebra. So second one is non-procedural language. So in this case we no need to instruct or specify the method in how to extract the data from the database. So that is considered as relational calculus. So it mostly represents the symbolic data. So mostly we can't able to execute the relational calculus, but we can sample the more relational algebra concept comes under the procedural language. So mostly procedural languages are considered while designing the database in order to effective extraction of the data